Before we jump into the declaration, it's vital to comprehend what molecule gas pedals are. The Huge Hadron Collider, LHC, worked by CERN, is a 17M ring of superconducting magnets and the world's biggest and most remarkable atom smasher. It represents the zenith of human scientific accomplishment. Truth be told, it's so powerful that it can reproduce the physical states of the universe's introduction to birth. But could this machine, designed to unlock the mysteries of the universe, hold the key to something far more ominous? CERN, established in 1954, is one of the world's most prestigious research organizations. With 23 member states and thousands of scientists, it's a hub for collaboration and innovation. The LHC is CERN's flagship project, yet it's only one part of a vast network of accelerators and experiments. Imagine a circuit, not for cars or horses, but for subatomic particles in a race against time and space itself. The LHC accelerates protons to nearly the speed of light, sending them on a collision course that replicates the energy of the universe at the time of the Big Bang. The collisions create temperatures millions of times hotter than the core of the sun. Thousands of magnets guide the protons on their journey, while complex cooling systems keep the magnets at temperatures colder than space. The beams inside the LHC collide at 4 points around the accelerator ring, corresponding to the locations of 4 particle detectors: Atlas, CMS, ALICE, and LHCb. Each serves a unique purpose, exploring different aspects of particle physics. Together they act as giant cameras, capturing snapshots of these collisions. Scientists then sift through the debris, searching for signs of the elusive Higgs boson, also known as the God particle, and other phenomena that offer clues to the universe's fundamental building blocks. By studying the microcosm, we gain insights into the cosmos. But with each answer comes another question, and with each discovery, another challenge. The LHC isn't just a scientific instrument. It's a testament to human curiosity and innovation. It embodies our relentless pursuit of knowledge and our desire to understand the fundamental forces that shape our universe. But as we push the boundaries of what we know, we must also consider the ethical and existential questions that arise. What are the risks of probing the unknown? Could our quest for understanding accidentally unleash forces we cannot control? In the hallowed halls of CERN, where the limits of human understanding are constantly tested, a discovery has emerged that sends a shiver down the spine of even the most seasoned scientists. Brian Cox, a former researcher at CERN and a respected voice in the world of particle physics, has recently made an announcement that has left the world both awestruck and apprehensive. Cox's words resonate with haunting clarity. The goal of CERN's Large Hadron Collider is to recreate a miniature Big Bang. Yes, you heard that right, a small version of the very event that birthed our universe. The physicist also explained the implications of this goal, highlighting the LHC's extraordinary potential for groundbreaking discoveries. This includes its ability to unlock the secrets of the Higgs boson and explore dark matter, a mysterious substance that makes up a significant portion of the universe. Imagine harnessing the power of creation, the ability to summon the very essence of the universe. It's a tantalizing prospect, but one fraught with danger. The miniature Big Bang isn't a theoretical concept. It's a tangible reality within the LHC. The temperatures, pressures, and raw energy all mimic the conditions of the universe's inception. It's like standing at the very beginning, witnessing the birth of existence itself. But with such power comes responsibility, and the question looms: what if something goes wrong? In fact, something did go wrong back in 1978. The Russian physicist Anatoly Bugorsky experienced a disaster that would forever change his life. While working on the UP-70 synchrotron at the Institute for High-Energy Physics in Protvino, Russia, a malfunction led to his head accidentally coming into the direct path of a proton beam. The beam, with a power that defies comprehension, passed through his skull, entering the back of his head and exiting through his nose. Bugorsky's experience was extraordinary. He saw a flash brighter than 1,000 suns but felt no pain. The beam's path left a trail of destruction, burning through tissue and bone, yet he remained conscious and even walked to the clinic for treatment. The aftermath was both horrifying and fascinating. The beam's path caused localized tissue death, leading to the loss of hearing in one ear and partial facial paralysis. Yet, remarkably, Bugorsky's intellectual abilities remained intact, and he continued his scientific career. This incident is not just a personal tragedy but a cautionary tale that underscores the immense power and potential danger of particle accelerators. The risks of a machine like the LHC are not to be taken lightly. The potential for unforeseen reactions and the manipulation of the very fabric of reality are real concerns voiced by some in the scientific community. One of the most unsettling and captivating concerns associated with the LHC's experiments is the possibility of creating a miniature black hole. Black holes are regions of spacetime where gravity is so strong that not even light can escape. They are cosmic vacuum cleaners, devourers of stars, mysterious entities lurking in the shadows of our universe. That the LHC could create such an entity, even on a tiny scale, is shocking to both the general public and experts alike. Could this black hole grow uncontrollably, swallowing the Earth from within? While scientists at CERN have assured us that any black hole created would be unstable and vanish instantly, the remote possibility has sparked debates, fears, and a sense of awe at the power we wield. It's essential to understand how the LHC could create a black hole. It has to do with the fundamental mechanics of particle accelerators. When protons collide at nearly the speed of light, the energy released is so massive that it warps the fabric of spacetime itself. Imagine a trampoline stretched tight, and then a heavy weight is dropped onto it. The fabric bends and distorts, and if the weight is heavy enough, it could create a depression so deep that anything nearby would be pulled into it. That's a simplified analogy for what could happen in the LHC. In the world of quantum physics, where the rules of the universe are both strange and beautiful, there exists a theory that extra dimensions may be hidden within our universe. If these dimensions exist, the LHC's collisions could exploit them, creating a gravitational funnel that forms a microscopic black hole. This mysterious dance of particles has even drawn the attention of some world-renowned scientists, particularly the late Stephen Hawking. In his book, he warned of a scenario where the Higgs boson could become unstable at very high energy levels. This instability could lead to a catastrophic vacuum decay, a cosmic event that would not only destroy the Earth but the entire universe itself. The esteemed British cosmologist and astrophysicist Sir Martin Rees likewise communicated his interests about the trials directed at CERN in his book on the future possibilities for mankind. He investigated the potential dangers related to atom smasher tests, including those at CERN. His words were not simply preventative. They were touched with a feeling of existential fear. He discussed a worst-case scenario where a disastrous analysis could create a condition considered vacuum shakiness. This instability could, in theory, set off a phase change that would echo through the actual fabric of spacetime, resulting in a vast disaster that could overwhelm the whole universe. Rees' concerns were not limited to theoretical insights. He assigned a probability to these devastating outcomes, albeit a low one. Yet even a minute chance, he argued, ought to give us pause. The stakes are impossibly high, and the margin for error is razor-thin. The scientists at CERN have calculated the probabilities, run the simulations, and analyzed the theories to argue for the safety of the LHC. In fact, Brian Cox himself acknowledged the importance of careful scrutiny, recognizing that there are widespread fears and concerns surrounding the activities of the LHC. He emphasized that there are rigorous safety measures in place, extensive reviews, and protocols that ensure the LHC's operations are conducted with extreme care. Cox reassured the public that the energies involved are well within what the Earth naturally encounters, and the chances of creating a stable black hole are astronomically low. Even if one were created, scientists say it would be so small and so unstable that it would dissipate instantly into energy, a phenomenon predicted by Stephen Hawking known as Hawking radiation. It would be a brief moment of cosmic wonder, a glimpse into the abyss, and then gone. Some have gone further, speculating that the LHC's experiments could open a portal to another universe or dimension. This idea, though largely dismissed by mainstream science, has captured the imagination of many and has become a subject of interest, fear, and even mythology. What lies beyond our world? Could we accidentally unleash forces or entities that we do not understand? The notion of opening a gateway to hell has even been dramatized in various media, fanning the flames of uncertainty. But how did this idea arise, and what does it mean in the context of scientific exploration? The concept of parallel dimensions isn't new in physics. String theory, a leading candidate for a unified theory of everything, suggests that there may be more than the familiar three dimensions of space and one of time. These additional dimensions could be compactified or hidden from our perception, but they could theoretically be accessed or revealed under extreme conditions. Now, imagine the LHC as a cosmic key, unlocking doors that have been sealed since the dawn of recorded history. When protons collide at energies never before achieved on Earth, they could, in theory, create ripples or tears in the fabric of spacetime, forming temporary gateways or tunnels to these hidden realms. While much of this remains in the realm of science fiction, it's hard to ignore the weight of possibility. At the heart of this discussion lies the question of responsibility. Should we be tampering with forces that could potentially alter the fabric of reality itself? With the LHC's ability to probe the deepest corners of existence, should we be concerned about what we might uncover? As Brian Cox and other scientists continue to explore the mysteries of the universe, one thing is certain: the pursuit of knowledge comes with risks. The quest to uncover the unknown is fraught with dangers, both seen and unseen. The story of the LHC is more than just a tale of cutting-edge science. It is a story of humanity's insatiable thirst for understanding. With each experiment, each discovery, the universe reveals itself to us in ever more complex and awe-inspiring ways. Yet the question remains: when we unlock the deepest secrets of the universe, are we prepared for the consequences? Or will we, like Norbert Wiener, find ourselves standing at the edge of the unknown, staring into a universe that we may not fully understand or control? The answer to that question lies in the future, a future filled with both promise and peril. As we stand on the precipice of discovery, we must ask ourselves: are we truly ready to face what we might unleash? As we consider the future of the LHC and the potential risks and rewards of its groundbreaking experiments, it's important to recognize the broader context of our scientific curiosity. The Large Hadron Collider is not just a device designed to answer theoretical questions about particle physics. It represents the essence of human exploration. From the earliest days of civilization, we have sought to understand the world around us. In ancient Greece, philosophers like Aristotle attempted to unravel the mysteries of the universe through logic and observation. Millennia later, the Renaissance gave birth to modern science, with figures such as Galileo and Newton fundamentally changing the way we understood the natural world. The LHC is the latest and most powerful tool in our ongoing quest to uncover the universe's mysteries. Yet with this exploration, we cannot ignore the profound responsibility that comes with delving into the deepest parts of nature. As we push the boundaries of science, we are also pushing the boundaries of what we can control. The potential to uncover knowledge about dark matter, antimatter, and even the fundamental nature of reality itself is incredibly alluring. However, every step into this uncharted territory must be taken with caution. Our understanding of physics is still incomplete, and with that incompleteness comes the risk of misinterpretation or unforeseen side effects. The idea of a particle collider causing unforeseen events, such as the creation of black holes, has captivated the public imagination. Yet, the scientific community has long acknowledged the complexities involved. Most scientists working at CERN are confident that the accelerator will not bring about any catastrophic event. They rely on extensive modeling and theoretical frameworks that support the safety of these experiments. For example, string theory suggests that any micro-black holes created would quickly decay due to quantum effects. Thus, even if a miniature black hole were formed, its lifespan would be imperceptibly short, vanishing in an instant. But despite these reassurances, there are those who argue that we cannot predict every possible outcome. The nature of the LHC's experiments requires them to operate at the edge of current scientific understanding. This means that while the LHC's work is grounded in established theories, it is also paving the way for entirely new questions and paradoxes. The danger of creating something entirely unexpected, a phenomenon that doesn't fit into our current models, is real. As science fiction and speculative thought experiments often suggest, The consequences of exploiting unknown forces could be more far-reaching than we can possibly imagine. Some critics of the LHC experiments worry that our society has become so focused on the pursuit of knowledge that we may not fully understand the consequences of our actions. There is a growing philosophical debate about whether humanity, in its thirst for knowledge and progress, is walking too close to a precipice. Some argue that we should adopt a more cautious approach, focusing on what is immediately beneficial to society rather. On the other hand, there are those who believe that science is inherently valuable, regardless of risks. They argue that to truly advance human knowledge, we must confront the unknown, even at the cost of uncertainty. This balancing act between scientific curiosity and caution is not a new dilemma. It is a question that has been raised time and again throughout history. The development of nuclear power, for example, brought similar concerns in the 20th century. The potential for atomic energy to transform our world was undeniable, yet the risks of nuclear weapons and radiation poisoning were ever present. Despite these fears, humanity's commitment to exploration and technological advancement did not waver. Similarly, the LHC's research could yield breakthroughs that transform not only our understanding of physics but also the very nature of existence. It is not just a new frontier of science but of human potential. As we look forward, it's also worth considering the ethical dimensions of these experiments. The LHC's research is conducted in the name of discovery, but is discovery a sufficient justification for the risks involved? With each experiment conducted, new technologies and techniques are developed, many of which have applications beyond the world of physics. The knowledge gained could lead to advancements in fields ranging from medicine to material science. However, with the possibility of unintended consequences looming, it is crucial for scientists to maintain an ongoing dialogue with the public and policymakers. Transparency is key in ensuring that the benefits of the research are weighed against any potential dangers. In the end, the LHC represents more than just a scientific endeavor. It symbolizes humanity's relentless drive to push the boundaries of what is possible. Whether we are truly prepared to confront the consequences of these experiments remains to be seen. What is certain, however, is that the questions posed by the LHC, about the origins of the universe, the nature of matter, and the fundamental forces that govern reality, will continue to shape our understanding of the cosmos for generations to come.